Hello everyone, Ramya, Assistant Professor of CSC Department from Rohini College of Engineering and Technology, subject code CS8602, Compiler Design, Unit 4, Topic Heap Management. The heap is the portion of the store that is used for data that lives indefinitely or until the program explicitly deletes it. The local variables may be needed by many programming languages even after the procedure in which was declared gets completed. Here the memory manager is a subsystem that allocates and deallocates space within heap. It serves as an interface between application programs and the operating system. It is also responsible for deallocation when operation like free or delete is used by languages C or C++ manually. Garbage collection is an important subset of memory manager. It is the process of finding spaces within the heap that no longer need and therefore be allocated for other data item. Java uses garbage collector for deallocating memory. Next we are going to see the memory manager. That means it is used to keep track of all the free space in heap storage at all times. It performs two basic functions. One is allocation and the next one is deallocation. First one is allocation. When a program requests memory for a variable or object, the memory manager produces a chunk of contiguous heap memory of the requested size. The next one is deallocation. The memory manager returns deallocated space to the pool of free space, so it can reuse the space to satisfy other allocation requests. Next, we are going to see the properties of memory manager. In that first, we are going to see the property space efficiency. That means a memory manager should minimize the total heap space needed by a program. Doing so allows larger program to run in a fixed virtual address space. Here the space efficiency is achieved by minimizing fragmentation. The next one is program efficiency. A memory manager should make good use of the memory subsystem to allow programs to run faster by attention to the placement of objects in memory. The memory manager can make better use of space and hopefully make the program run faster. The next one is low overhead. Memory allocations and deallocations must be efficient as possible. It is used to minimize the fraction of execution time spent performing allocation and deallocation. Next, we are going to see the memory hierarchy of a computer. In this diagram, a processor has a small number of registers whose contents are used under software control. The next one is it has one or more levels of cache, usually made out of static RAM, that are kilobytes to several megabytes in size. The next level of the hierarchy is the physical or main memory, made out of hundreds of megabytes or gigabytes of dynamic RAM. The next one is the physical memory is then backed up by a virtual memory, which is implemented by a garbage of disks. Upon a memory access, the machine first looks for the data in the lowest level storage, and if the data is not there, means it looks in the highest level. Likewise it will look. Here the registers using it is managed by the code that compiler generates. All the other levels of the hierarchy are managed automatically. Here the data is transferred as blocks of contiguous storage between main memory and cache. Then only the data is transformed in block known as cache lines. It is typically from 32 to 256 bytes long. The next one is locality in programs. A program has temporal locality if the memory location is accessed or likely to be accessed again within a short period of time. A program has spatial locality if memory locations close to the location accessed or likely also to be accessed within a short period of time. Next, we are going to see the reducing fragmentation. At the beginning of program execution, the heap is one contiguous unit of free space. As the program allocates and deallocates memory, this space is broken up into free and used chunks of memory. The free chunks of memory as wholes with each allocation request. Here the memory manager must place a requested chunk of memory into a large enough hole. That means here the hole of exactly the right side is found. We need to split some hole, creating a yet smaller hole. The next one is best fit and next fit object placement. That means here the fragmentation can be reduced by controlling the placement of few objects. That memory manager, the best fit algorithm can be used to satisfy the larger requests. An alternative called the first fit algorithm places in the first hole which fits in and takes less time compared to best fit. Here the implementation of best fit placement more efficiently, we can separate free space into bins according to their sizes. There is a bin for every multiple of 8 byte chunks from 16 bytes to 512 bytes. There is always a chunk of free space that can be extended by requesting more pages from the operating system. It is called as wilderness chunk. Then next we are going to see the managing and collapsing free space. When an object is deallocated manually, the chunk can be made free and it possible can combine with the adjacent chunk of larger chunk. If a bin for chunk is of fixed size, then no need to combine. It is simpler to keep all chunks of one size in as many pages as needed. That means a simple or deallocation scheme is to keep a bitmap, one bit for each chunk in the bin. Here 1 indicates the chunk is occupied, 0 indicates it is free. When a chunk is deallocated, we change it from 1 to 0. When we need to allocate a chunk, we find any chunk with a 0 bit. Change that bit to a 1 and use the corresponding chunk. Next we are going to see one diagram here. At the A, B and C, and the chunk of size 100 has just been deallocated and written to the free list. The left end of B, namely A, is free, which is known by the 0 value in right of A. So we can combine A and B into one chunk of 300 bytes. The chunk C, right to B, is not free, which is known by the value 1 in start of C. If chunk C is free, then A, B and C can be combined. If A and B has to be combined, need to remove one of them before and after each of A and B. Then only automatic garbage collection can eliminate fragmentation altogether if to move all the allocated objects to the contiguous storage. Thank you.